Today we are going to discuss Edexcel IAL Chemistry January 2020 paper 2. So let's start with the MCQs first. So move on to section A. Which equation represents the standard enthalpy change of formation of hydrogen iodide? Now, for the standard enthalpy change of formation means that 1 mole of a substance is formed from its element in their standard state. So if you will look here, in the first equation, iodine is not present in its standard state, so this cannot be the option. In the second equation, 2 moles of a substance is formed, so this cannot be the option. In the third equation, iodine is not present in the standard state, so this is also not a correct option. And in the fourth one, hydrogen is present in the form of a gas in its standard state. Iodine is also present as a solid, which is its standard state at room temperature, and 1 mole of hydrogen iodide is formed. So this is the correct option. Now move on to question number 2. When 50 centimeter cube of hydrochloric acid of concentration 2 moles per decimeter cube is added to 50 centimeter cube of sodium hydroxide solution of concentration 2 moles per decimeter cube, the temperature rises 13 degrees centigrade. The experiment is repeated using 25 centimeter cube of the same hydrochloric acid and 50 centimeter cube of the same sodium hydroxide solution. Oh, okay. So in the first experiment, when they performed the experiment for the first time, they have used 50 centimeter cube of hydrochloric acid and 50 centimeter cube of sodium hydroxide of to concentration 2 moles per decimeter cube of both the sodium hydroxide as well as hydrochloric acid. Then the temperature increase was 13 degree. But when they repeated the experiment, what happened? They have reduced the volume of HCl to half. Now you need to calculate the temperature change when they repeat the experiment using half of the volume of hydrochloric acid. So in experiment 1, the change in temperature is 13 degrees centigrade, and number of moles of hydrochloric acid were concentration multiplied by volume. 2 into volume was 50 centimeter cube. It means 50 divided by 1000 decimeter cube. So the number of moles of hydrochloric acid was 0.1 moles when the experiment was done for the first time. And when the experiment repeated the second time, the number of moles of hydrochloric acid changes. The concentration remains the same, but the volume changes to 25 centimeter cube, and you will convert that into decimeter cube. So the number of moles of hydrochloric acid will change to 0.05 moles. So now you need to calculate the temperature change for the second experiment. Now you will use the formula here, delta T2 divided by delta T1 is equal to N2 into V1 over V2 over N1. And here you need to calculate change in temperature in the second experiment. So you will rearrange the equation and now put the values here. Delta T1 is 13 and 2.05. V2 is 0.025 decimeter cube. V1 was 50 centimeter cube. It means 0.05 decimeter cube divided by N1, 0.1 moles. So if you will calculate, the value is 8.7 degree. So this is the correct option. Now move on to question number 3. Nitrogen reacts with hydrogen to form ammonia, and you need to find the mean bond energy in kilojoules per mole for nitrogen hydrogen bond. So look at the question carefully. You need to find the mean bond energy of 1 mole of nitrogen hydrogen bond. Okay, so you will use the formula here. Enthalpy change of reaction is equal to enthalpy change of the bond breakdown minus enthalpy change of the bond form. You have the enthalpy change of the reaction minus 92, and the bond form breakdown are basically nitrogen bond will break down, that is 945, and here you know there are three hydrogen hydrogen bonds, so you will multiply 436 with 3, and how many bonds are formed here? In 1 mole of ammonia there are 3 nitrogen hydrogen bonds. So if there are 2 moles of ammonia, it means 6 nitrogen hydrogen bonds. So if you will consider it as x and you will rearrange the equation, then 6x is equal to 2253 plus 92, 5 divided by 6, so the value of x will be 391. So the mean bond energy of one nitrogen hydrogen bond is 391 kilojoules per mole. Now move on to question number 4. How many moles of carbon dioxide are formed when 3 moles of chloroethene is mixed with 10 moles of oxygen and react as shown? Okay. Now you know that 2 moles of chloroethene react with 4 moles of carbon dioxide. Now 2 moles react with 4 moles, it means 1 mole react with 4 over 2. And you have how many moles of chloroethene? 3 moles of chloroethene. So it reacts with 6 moles of carbon dioxide. So this is the correct option. Now, which compounds are arranged in order of decreasing boiling temperature? You decreasing. So in option 1, you can see here that the chain length is increasing. So it means the boiling temperature must increase as the chain length increases. So, and here they are showing that this has the highest temperature, so this is the correct wrong option. In the second option, you can see that this is a long chain. It also has the same number of carbon, but there is a branch, and it also has the same number of carbon, but there are branches. So as the branch is increases, the boiling temperature decreases. Okay, so this will have a highest boiling temperature than this, and this has the lowest. So this is the correct option. Now question number 6. Chlorine is added to 2 centimeter cube of dilute solution of potassium iodide. The equation for the reaction between chlorine and iodide ion is. Which statement is correct? You know, chlorine is above iodine in group 7, and chlorine has a more oxidizing ability as compared to iodine. So it oxidizes iodine. Because chlorine oxidizes iodine, so itself gets reduced. So it means iodide ion reduce chlorine. So this is the correct option B. When the reaction is complete, 10 centimeter cube of cyclohexane density 0.74 gram per decimeter cube is added. The mixture is shaken and left to settle into 2 layers. Which description of one of these layers is correct? You know, when you will add cyclohexane into the solution containing iodine, what will happen? That cyclohexane will dissolve iodine. Okay, and a layer will form which has a density less than the density of water. So the water layer will be at the bottom and the cyclohexane layer will be at the top. And due to the presence of iodine, the upper layer will be purple. So the correct option is A. Now, question number 7. Going from calcium to barium in group 2, which property changes as stated? As you go down the group, the ionic size will increase. The size of the ionic radius will increase. As a result, what will happen? That it would be easier to remove the electron because the distance of the electron of the outermost orbit from the nucleus will increase. So, the option is the first ionization energy will decrease. Now question number 8. The properties of group 2 compounds changes down the group from magnesium to barium. As you go down the group from magnesium to barium, you know the solubility of group 2 sulfates, it increases, it decreases, not increases. You know barium sulfate is less soluble, so this is the wrong option. The solubility of group 2 hydroxide also it increases basically, not decreases. So this is also a wrong option. The thermal stability of group 2 nitrates increases. As you go down the group, the size of the atom will increase. As a result, the ability of the cation to polarize the anion will decrease, so that there will be strong ionic bond. As a result, they will become more thermally stable. So the correct option is thermal stability of group 2 nitrates increases down the group. Now next question, question number 9, you need to balance the equation. How you can balance the equation? Look at the equation and balance it. So it will be 6, 3, 5, 1 and 3. So the correct option is D. Now move on to question number 10. Aqueous sodium iodide reacts with aqueous silver nitrate to form a precipitate of silver iodide. Which is correct for silver iodide? You know the color of iodide precipitates is yellow, and iodide precipitates are insoluble in dilute as well as concentrated ammonia. So the correct option is A. What is the percentage atom economy by mass for the production of silver iodide? How you can calculate the percentage atom economy? By taking the mass of your desired product divided by the total mass of the reactants, and you will multiply with 100 because you are calculating the percentage economy. So 234.8 divided by 149.9 plus 169.9 into 100 to find the atom economy, and that is 73.4%. So the correct option is D. Now, ethanol can be prepared by reacting chloroethane with aqueous potassium hydroxide. You know, because you are using aqueous. So, question number 11, ethanol can be prepared by reacting chloroethane with aqueous potassium hydroxide. What type of reaction occurs in this preparation? So, this reaction is basically because the OH ion will replace the chlorine. So, this is a substitution reaction. Now, how do the boiling temperatures of ethanol and chloroethane compare, and what is the reason for the difference? Basically, ethanol has a higher boiling temperature due to the presence of hydrogen bonds. So, the correct option is A, that ethanol is higher, ethanol molecules form hydrogen bonds. Bromo, ethane and chloroethane, they react with aqueous potassium hydroxide at different rate, which is correct. You know, in bromoethane, there is a bond between carbon and bromine, and in chloroethane, carbon and chlorine. You know, carbon chlorine bond is stronger than carbon bromine bond. This bond is weaker. So, as a result, it can break easily. So, this gives a quicker reaction. So, the rate of bromoethane is faster due to the carbon bromine bond, which is weaker than carbon chlorine bond. Now, question number 12, butanol burns completely in oxygen. 7.4 grams of butanol was burned completely in 16 decimeter cube of oxygen, and the final mixture produced was cooled at RTP. What is the final volume of gases, mixture of gases in decimeter cube at RTP? You know, here butanol is the limiting reactant. It burned completely in the presence of oxygen. So oxygen will be in excess, and at the end carbon dioxide gas will produce, and the oxygen which will remain left after reaction with butanol will also be left in the reaction mixture at the end. So at the end we need to find the total volume of the mixture of gases, which will be the total of the remaining oxygen gas which was left after the reaction with butanol as well as the carbon dioxide gas. So let's start the question. First, you need to find the moles of butanol which are present in the reaction mixtures. So the moles of butanol is equal to mass over MR. Mass of the butanol is 7.4. MR is 74. So moles of butanol is 0.1. Then you need to find the moles of oxygen. And here the volume of oxygen is given 16 decimeter cube. So moles of oxygen is equal to volume over molar volume. So 16 decimeter cube is a volume and 24 is a molar volume. So you need to calculate the number of moles, and that's equal to 0.667 moles. Now you have the moles of oxygen as well as the moles of butanol. Okay. Now you know that 1 mole of butanol react with 6 moles of oxygen. So you have 0.1 mole of butanol. So it reacts with 0.6 moles of oxygen. But in the reaction mixture, you have 0.667 moles of oxygen. So from 0.667 moles, if only zero point 0.6 moles will be reacted, so the number of moles of oxygen which will be left after the reaction will be equal to 0.067 moles. So these moles of oxygen will be left in the reaction mixture. And you know that 1 mole of butanol react with 4 moles of carbon dioxide. So 0.1 mole of butanol react with zero point 0.4 moles of carbon dioxide. So at the end, in the reaction mixture, we have the gases 0.4 moles of carbon dioxide and 0.067 moles of oxygen. These are the total gases which will be left in the reaction mixture once the reaction will be over. So the total moles are 0.467 moles. But we need to find the volume. So we will multiply this with the molar volume, that is 24. So the total volume of the gases in the reaction mixture is 11.2. So B is the correct option. Now, if the final volume of gases is passed through a U tube containing sodium hydroxide, what is the final volume of gas in centimeter cube? So the final mixture contains carbon dioxide gas as well as the oxygen gas which left after reacting with butanol. So when you pass carbon dioxide, it reacts with sodium hydroxide, it will be absorbed. So only oxygen gas will be left in the reaction mixture. So the moles of oxygen which are present is equal to 0.067 moles of oxygen. So you need to convert this into volume, and because you need to convert this into decimeter cube, from the decimeter cube into centimeter cube, so you will multiply with the 1000 as well. So if you will do this, the answer is 1600 centimeter cube. So the correct option is the B. Now question number 13, a halogenoalkane is dissolved in aqueous ethanol. When aqueous silver nitrate is added, a white precipitate form immediately. Now what is a halogenoalkane? You know the chlorine, basically chloride ion, form white precipitates and all contain chloride ion. So which precipitate will form very quickly? You know, if you will compare the primary halogenoalkane, secondary halogenoalkane and tertiary halogenoalkane, so the most reactive, the one which gives the reaction very quickly, is tertiary halogenoalkane. So it means that the tertiary halogenoalkane will react more quickly and will give the precipitates immediately. So among these, the Correct option is D because this is tertiary halogen alkane. Now, question number 14, propanol and propanone. Aldehyde and ketone are isomers. Which M over Z peak would be expected in the mass spectrum of propanone? This is propanone. So, if you will look at the structure and you find the peak, the molecular ion, if you will calculate the MR of the propanol, then the molecular ion peak will come at 58. And what would be the other options of the peak? One of the option is that the propanone breaks in this way. So the peak will obtain at 43 and the, the peak at CH3 will be obtained at 15. So there will be no peak at 29. So 29 is the correct option. Now last question, propanol and propanone can be distinguished by chemical test. This is an aldehyde and this is a ketone. So these tests can be used. Warm with Phallic solution, propanol no change, propanone red precipitate. This is wrong because here the propanol will give a positive test and there will be no change in propanol. So this is the wrong answer here. Add solid phosphorus pentachloride no change, misty fume. This is also wrong. This is a test for OH group. Warm with acidified potassium dichromate turns green and no change. Okay, this is the correct option because the aldehyde will be oxidized. The primary alcohol will be oxidized into aldehyde and then aldehyde into the carboxylic acid. There will be no change with the ketone. And so this is the correct option, part C. So this is all for part 1 of 2020 January paper 2.